The United Blood Services is a blood bank that serves more than 500 hospitals in 20 states. According to their website, a person with type O blood and a negative Rh factor can donate blood to any person with any blood type. Their data shows that 40% of people have type O blood, 11% of people have Rh negative factor, and 48% of people who have type O or the negative Rh factor. We're going to use this information to find the following probabilities. So let's identify the information that we have. I'm going to come down here and let's see. I'm going to say that O represents the event that someone has type O blood. And it says in the example here, it says that there are 40% of people that have type O. So I'm going to put the probability of having type O is 0.4. Then it goes on to say that if there is an Rh negative factor, that's a probability of 11%. So I'll call that event R. And that's going to have a probability of 0.11. Then the last piece of information that's given to us is that 48% of people have either O or the Rh negative. So I'm going to put down that the probability of event O or event R is 0.48. Now we're going to use this information to find part A. It says, find the probability that a person has both type O and the Rh factor. So what we're trying to find is the probability of O and R using the information and the formulas that we have. So if we look up here, we can use the OR formula for this because we have pretty much everything we need. I don't want to use the AND formula because I don't have any of the conditional information. So that kind of omits using these formulas here. But if you notice, if I replace C with O and I replace D with R, I can figure out what O and R is because we have everything else. I have the value for the probability of O or R. I have the probability for R and I have the probability for O. So literally, I'm just going to plug in the values I have and solve for this part, the AND portion. The probability of C or D, or actually, my bad, the probability of O or R we found was 0.48. So I'm going to plug that in here. So that's going to go in for my OR statement. The probability of R we said was 0.11 plus the probability of O was 0.4. And then we're going to subtract the probability of O and R. That's what we're looking for. That's our unknown. So to solve this is a very basic algebraic equation. I have to solve this equation for this right here. So what I'm going to do is I'm going to subtract 0.11 from both sides, and I'm going to subtract 0.4 from both sides. So what I'm left with on this side is negative P, O, and R. So when I take 0.48 and I subtract 0.11 and then subtract 0.4, I'm going to get negative 0.03. And then if I know that the negative value of this probability is equal to negative 0.03, I know that this probability of O and R must be 0.03. Or another way you could do it is just thinking about this in terms of algebra. If I want to get rid of the negative sign, I just multiply both sides of the equation by a -1. When I multiply negative 0.03 times a -1, that changes to a positive. And when I multiply this side by -1, that changes to a positive. So I know that the probability of O and R is equal to 0.03. Now, for part B, it says find the probability that a person does not have both type O blood and the Rh negative factor. So what that's asking is the complement of this. We want to find everybody that doesn't have this O and R. So if I find the complement of 0.03, that's going to be 0.97.